So the topic is fits and types of fits. Here we're gonna discuss what is fits, types of fits and their application. So now we're gonna see what is fit. Fits is defined as how much tight or looseness exists between two mating parts when they are assembled together to carry out the specific function. Okay. Also, there exists some relationship between two mating parts with respect to the amount of play, that is the clearance or a tightness, when they are assembled together. According to this, fits may be divided or categorized into two parts, that is the movable fits or a fixed movable joints or a fixed joints. For example, a shaft running on a bearing can move in relation to it, and thus it form a movable jaw, where a pulley mounted on the shaft forms a fixed joint. Means in one the shaft is running on a bearing, so this is called a movable joint, and in another case where the pulley is mounted on the shaft, so it is a fix. So here there are two classifications. Now we will see the types of fits. So basically there are three types of fits: clearance fit, interference fit, transition fit. So in clearance fit, the shaft diameter is always less than the hole diameter, and in interference fit the hole diameter is always less than the shaft diameter, whereas in the transition fit the hole diameter and shaft diameter are equal as shown in the picture. Now what is maximum clearance and minimum clearance? Maximum clearance, it is a difference between the minimum size of the shaft and maximum size of the hole, whereas minimum clearance is a difference between the maximum size of a shaft and minimum size of a hole. As you can see in the clearance fit, there exists maximum clearance and minimum clearance, same as in interference fit there is maximum interference and minimum interference, but in transition fit there is maximum clearance and minimum interference, as transition fit exists between these two fits, that is clearance fit and interference fit. As I said earlier, there are basically three types of fit: clearance fit, interference fit and transition fit. There also exist the subtypes of these fits which are shown in these slides. Transition fit will be carried out by myself, and clearance fit and interference fit will be carried out by my friend Jain Harshit. Now we will see what is transition fit. Transition fit exists between these two fits, that is clearance fit and interference fit. And in transition fit, after assembling any two mating parts, then only we come to know that the parts assembled are of clearance fit or interference fit, as this depends on the actual size of the parts. Means after assembling we come to know that this part has a clearance fit or interference fit. We cannot predict beforehand. Okay. And in this there is zero tolerance zone between shaft and hole. Means that tolerance zone which is there in shaft and holes are overlapping each other, that is there is no clearance left between these two mating parts after they are assembled. This is what the transition fit is all about. Now we will see the subtypes of the transition fits. There are two subtypes of the transition fit. First is a wing ring fit and second is the push fit. First we will see what is wing ring fit. It provides the zero interference or clearance. Means after mating two parts there is no interference or clearance left between two mating parts, and this type of fit is used where the parts can be easily replaceable during the minor repairs, for example the gear of the machine tools. Now what is push fit? In push fit it provides only small clearance, means there is only very much little clearance between two mating parts when they are assembled together, and this assembly has to be carried out by hammering or by pushing the two mating parts. Thus its name itself is a push fit, and this fits is used for disassembling during the operation of the machine. For example, the change gear and the split bushing. These are the example of push fit. Now we will see the mechanical application of transition fit. Coupling rings and races, gear and bearing bushes, spigot in mating hole means it requires pressure to force the spigot into the mating hole so that it could carry out its function. Next is fixing keys and pins in the keyways so that it could transfer the motion from the shaft to the gear to carry out its function. Same way, the parts which are frequently dismantled but are secured by the keys, example pulley, hand wheels, piston on the piston rod, etc. These all are the examples of the transition fits which are used in day-to-day life in mechanical engineering. Thank you. Further explanation will be carried out by my friend Harshit Jain.
Hey guys, what's up? Okay, my name is Harshit Jain, and today in this video we are going to cover the topic on clearance fit and interference fit. If you want to know more about the types of fits and transition fit, then you have to go to my friend's video, which is made by MANAN BHAVSAR. You can go through it. Okay, so without getting late, let's get started. Okay, so our first topic is the clearance fit. Okay, as the name suggests, the clearance fit, so which means that there some will be the airspace or clearance exist between the mating parts. Okay, some clearance fits, okay, which means that shaft rotate, or you can say the slide freely in the hole. Sometimes it is also referred as the sliding fit. Okay, such fits gives you the loose joint. Okay, now the definition of the book, we can say definition of the book, which means that largest diameter of the shaft is always smaller than the smallest hole diameter. Okay, so we can say that hole is always greater than the shaft. Okay, in terms of dimension, okay, means, okay, here is the definition. And a clearance fit will always give you the positive allowance. Okay, that means that there is minimum positive clearance between the high limit of shaft and low limit of the hole. Okay, due to the above said, shaft can rotate or slide through different degree of freedom according to the purpose of mating parts. Means it allows the rotation or sliding between the mating parts. Okay, now next we are going to see the pictorial representation of the clearance fits. So here is the pictorial representation of the clearance fit. So this is your hole, this is your shaft, this is the minimum dimension of the hole. That orange color portion here is your hole tolerance, this is your shaft tolerance. Again, minimum dimension of the hole is equals to basic size, which means that here we are using the hole basis system. Okay, so as the definition says that minimum dimension of the hole is always larger than the maximum diameter of the shaft. So here with the pictorial representation, it is very clear that minimum dimension of the hole is always larger than the maximum dimension of the shaft. Again, in clearance you will get maximum clearance and minimum clearance. So maximum clearance means it will equals to maximum dimension of the hole minus minimum dimension of the shaft. Okay, and likewise here also you will get for minimum dimension of the hole minus maximum dimension of the shaft, you will get maximum clearance and minimum clearance. Here you will see example. You can go through it by seeing these. Just apply, these are the main basic terms. You will get your basic size as well as the dimensions. Okay, this is just a representation, you can go through it. This is again a pictorial representation for not same. These both are also same, so you can also go through it. This is vertical representation, this is your horizontal representation, you can say like that also. Okay, now we are going to the next topic, which is the grades as well as the example of the clearance fit. Okay, these are given by as per the NC, as per the ANSI. Okay, so clearance fit is given by the RC numbers. Okay, representing by RC number. So lower the RC number, tighter the fits, higher the RC number, looser will be the fits. Okay, now next will be your RC1. RC1 is a close sliding fits. Okay, so close sliding means that this is basically required for accurate location where we doesn't want any type of play. Okay, means where you can't have any play because it will gives you a chance to get means there is no sliding. Okay, in short there will be no sliding, very less sliding, or you can see close sliding fits. So its definition will be like that. This kind of fits gives you accurate location of the parts for which must assemble without noticeable play. Okay, there will be no play. Okay, shafts are expensive to manufacture in this type of clearance because there will be very less sliding. Okay, example is given like H7G6. Again, the examples of this fits. Okay, every fits which we are discussing here will be on the last slide. I can also go. We can go through it. Okay. Next is the sliding fits. As the name suggests that there will be some clearance will be given between the mating parts so that the shaft can slide between the hole. Okay, this kind of fits also gives the accurate location and but have some maximum clearance than RC. Okay, but by giving the maximum clearance that doesn't mean that it can run freely. Okay, if there is a temperature changes, then sliding fits in larger size may cease. Okay, this is must you have to focus on that. If you are using the larger size, then sliding fits will then it may cease due to the small temperature changes. Okay, it will be RC3 precision running fits, as the name suggests that precision running fits. It will this kind of fit will run very freely. Okay, this fit is intended for precision work, means you have to do precise work at very low speeds. Okay, low bearing pressure at light general pressure. Okay, at that time precision running fits are required. Okay, RC3 means this is your limitation. RC3 is not suitable where noticeable temperature difference occurs. Okay, RC3 is not suitable. You have to go through it that RC3 is not suitable where noticeable temperature difference occurs. Next is close running fits, as the name suggests. Okay, this is mainly useful at moderate speed. Okay, moderate speed, moderate bearing pressure, where accurate location required. Okay, close running fits, as the name only says that there will be minimum play. Okay, example like suitable for lubricated bearing. Next is the free running fits. These fits are suitable for high running speed with considerable bearing pressure. Next is RC7, also a free running fit. Okay, but in this type of fit, there will be very less accuracy, where sometimes you require very less accuracy. Okay, where accuracy is not coming in the picture at that time, you can use the free running fit at where the temperature changes you can see. Okay, suppose you are having temperature changes and your parts are moving at high speed, then you require a free running fit. Okay, example is H9D10. Okay, S9D10, this D will be small. You can go to this D will be small. Okay. Okay. Now loose running fits. The loose running fit with this type of fit part have great amount of tolerance. Okay, means loose running fit, as the name suggests, only there will be so much tolerance will be given. Okay, having very great clearance. Okay, so due to the very great clearance, okay, this will shaft and hole will rotate or slide very easily, and due to which they are exposed to effects of corrosion or mechanical deformation, mainly suitable for loose pulley. Okay, now here the examples and grades of the clearance fits are over. Now we are moving to the interference fits. Okay, so interference fits, as the name gives you, that it is desirable for the shaft to be securely held within the hole. Means if you want to make a solid components with the parameters shaft and hole, then you require interference fits. Okay, in such cases, as a definition suggests, that in such cases the diameter of shaft is always larger than the diameter of the hole. Okay, in such cases diameter of the shaft means minimum diameter of the shaft will always larger than the maximum diameter of the hole. Okay, it is used for the components where motion power has to be transmitted. Okay, where motion power has to be transmitted, at the time interference fits are used. Thus, shaft and hole members are intended to be attached permanently and used as a solid component. As I have said, that these types of fits are required and solid component has to be made. Okay, and negative difference between the diameter of the hole and the shaft is called interference. In short, we can say that a negative difference between the diameter of the hole and the shaft is called the interference. Okay, and I have said that this type of fits are mainly useful for motion, power transmission, etc. Interference exists between the high limit of the hole and low limit of the shaft. Now we are moving for the grades and examples of the interference fits. Before moving that grades, have to do the pictorial representation. What we have said before the slide, you can go through it, as the interference fit is given. As the definition says that maximum dimension of the hole will always smaller than the minimum dimension of the shaft. Okay, again the maximum and minimum interference is seen here. You can go through it by viewing this figure, which is also basically same which we have explained before the slides in clearance fit. Again, there is also example is also provided, you can go through it. Okay, now we are moving the grades of and examples of the interference fits as per the ANSI. First is in these examples there will be a force or shrink fits. RC1 is the light drive fit. This type of fit are those which require light assembly pressure. Means when they are working at the light assembly pressure, we require less permanent assembly. At that time you can use the light drive fit. Okay. Now medium drive fit. Okay, medium drive fits means we will get the tightest fit when we are using the high grade cast iron external member. This type of fits are suitable for ordinary steel plates or shrink fits. Okay, on lighter section. Consider lighter section. Okay. Now next will be your heavy drive fit. This type of fits are suitable for heavier steel parts. Heavier steel parts or shrink fits in medium section. Okay, example H76. 76 where heavier steel parts, or you can say heavy sections are there, then you can use the heavy drive fit. Now force drive fit. Okay, FN4 and FN5 are the force drive fit. This type of fits are suitable where highly stress, means where the working of the mating components having the highly stress, high pressure, having high pressing force. At that time you can use the force driving fit. Examples are H7U6, H8X7. Okay, now here we are completing the examples as well as the grades of interference fit. Now as the last slide will be on the basis of applications of the clearance and interference fit. So this type of fit is symbol. Okay, as I have said that interference fit, transition fit and clearance fit. If you want to know the application of the transition fit, then you have to move to the my friend's video. Okay, you can go through it where he has explained the types of fit as well as the transition of the fits, and some other things related to the fits are also explained. You can go through it. Okay, now I am going to explain the interference fit and clearance fit. Okay, clearance fit with their application. Now firstly we are going for the interference fit. So Here you have the shrink fit, heavy drive fit, press fit, medium press fit. Okay, so firstly we are moving with the uh, shrink fit. Okay, shrink fit means it assembly of the hole and shaft. The hole is expanded by heating and then rapidly cool in its position. It is useful for fitting the rims, okay, wheel tires. Okay, here it is written that wheel tires and this type of things. You can uh, hole is getting expanded by heating and then rapidly cool down in its position. Okay, so there are the basic examples are wheel steel tires. Okay, bronze crowns on warm wheels, couplings, etc. Okay, then press fit. Press fit is basically required in the coupling in every type of coupling, okay, which you are using. Okay, and the coupling of shaft end. At the end of the shaft you require the press fit. Okay, when you are using the saddle key, sunk key, okay, feather key, at that time you require the press fit. Okay, press fit is required when couplings are there, which is the main you can say a very good example is basically for press fit is the coupling from the shaft ends. Okay, you can go through it by having any type of the couplings. Okay, and also in gear wheels, beer bushing in hubs, valve seats. Okay, medium press fit is this type of fits having negative allowance. Okay, medium press fit this type of fit having the negative allowance. Considerable pressure is required to assemble the hole and the shaft. It is used in the armature of the dynamos. Okay, this is used in the armature of the dynamos. Okay, now as the shrink fit and heavy drive fit, there is no that much change. Okay, uh, heavy drive fit is also working very same only and the shrink fit. Okay, now I am moving in the clearance fit. Clearance fits and it's basically their example. Okay, so here the precision sliding fits, as the name suggests that precision sliding means there will be not without noticeable play. Okay, there will be a very less play where very less play is required. So here is the best example is given the milling cutters on the milling manuals. If there will be the play, then there will be chances of you can go through it. And close running fits means some noticeable play with greater amount of clearance is there will be seen in the clutches, movable gears in the chain gear trains. Okay, normal running fits. Okay, normal running fit means the we can say that used in the bearing pair. Sometimes bearings on machine tool spindles and sleeve bearings with high revolutions. Okay, which can use. Now easy running fits, loose running fits and slack running fits. So easy running fits means sleeve having medium revolution. Okay, mainly useful for medium revolution. Okay, easy running fits. And wheel box is gear sliding and shaft on sliding blocks. Loose running fits is useful where having very less revolution. You can see sleeve bearing with less revolution. Slack running fit means having more clearance, more tolerance. Okay, so at that place you can use where large clearance is required. Okay, multi-spindle shafts, oil seals with metal housings, etc. I think that I have tried my best to cover the topics of all types of fits as well as the examples and uh, topics with grades and ANSI. I think there will be not have any problem in these types of fits because I have tried my best to explain all. So thank you to listening me. Thank you to see my video and thank you sir if you have seen this video. Thank you.